Hi everyone, my name is Thomas Kim. Today is December 24th, 2019. This is my 60th episode about linear algebra and threading building blocks. In this episode, I will discuss why pivoting is extremely important for the solution of the system of the linear equations. In my previous episode, episode 59, I explained why Gaussian Elimination Algorithm is important or useful. Before we discuss pivoting, I will remind you of rule number 1 of numerical analysis. Rule number 1. Division by very small number causes round-off error. So, I will create a function like this. Void is 0. This function takes two double A, double B. Then it calculates auto R A minus B over A times B. Then we print out R. If our computer is perfect machine, then R should always be 0 because B cancels out A minus A is 0. Now let's try this. Void is 0, double A, double B, or R A minus A over B times B. STD, C out, A equals A, STD, and there I will copy once again B, B, R, R, STD, and there. I created is 0 function, double, big, 1.0, double, small, 10.0, E minus 5 is 0, big, small, small, big. We are calling this function, and this function test 0 calls is 0 with big as A, small as B. In this case, small as A, big as B. Now start command prompt. dir cd60 pivoting clang ++ pivot.cpp, hit enter. cls. So in this case, A is 1 big number, B is 0.001, and the result is 0. In both cases, gives the same result, R is 0. Now I decrease this number 10. I build again, CLS. Now the result is different. So when B is 1, this is B. When B is 1, remainder R is 0. This is correct. When B is very small number, B is very small number, this result is wrong. It is not 0. So division by a very small number causes round-off error. So this result is not 0. It is incorrect. In this case, B is big number, 1. A is small number. Division small number with big number is no problem. It is still 0. Correct result. But division by a small number B, when B is very small, the result is incorrect. Naive Gaussian elimination. Epsilon x plus y equals 1, x plus y equals 2. This is a system of linear equations where epsilon is closer to 0. Selecting this element as pivot, we apply Gaussian Elimination Algorithm like this. Minus 1 over epsilon parenthesis epsilon x plus y equals 1, x plus y equals 2. It becomes minus 1 over epsilon x minus 1 over epsilon y equals minus 1 over epsilon x plus y equals 2. We add up together. Epsilon cancels out, minus x cancels out. It becomes 0 plus 1 minus 1 over epsilon y equals 2 minus 1 over epsilon. 1 over epsilon is a huge number. So 1 minus h y equals 2 minus h. 1 minus h is again minus h. 2 minus h again minus h. Because h is huge. So this equation becomes minus h y equals minus h. So y is approximately 1. If we substitute this result in this equation, epsilon x plus 1 equals 1, 1 cancels out, epsilon x equals 0, x is equal to 0. If we substitute this result, this equation, 0 plus 1 is 2. So this doesn't hold. This is incorrect. So this result is incorrect. Now scroll down. Gaussian elimination with correct pivoting. Epsilon x plus y equals 1, x plus y equals 2. Since this element is very small, close to 0, we swap two rows. Then we have x plus y equals 2, epsilon x plus y equals 1. Here is 1, and we select this one as pivot element. Pivot. Applying Gaussian Elimination Algorithm minus epsilon over 1. This is pivot element. Here, parenthesis, x plus y equals 2, epsilon x plus y equals 1. Then minus epsilon over 1 x minus epsilon over 1 y equals minus 2 epsilon over 1. This equation, epsilon x plus y equals 1. If we add up together, epsilon x minus epsilon x cancels out, 1 minus epsilon y equals 1 minus 2 epsilon. 1 minus epsilon is closer to 1. 1 minus 2 epsilon is closer to 1. So 1y equals 1. So y equals 1. If we substitute this result for y, x plus 1 equals 2, x equals 1. If we substitute this result to this equation, epsilon 1 plus 1 equals 1, because this term is 0. So 0 plus 1 equals 1. This equation true. So this result is correct. If we compare this result with this result, in this case we selected this element as pivot element. In this case we selected this element as pivot element. Now let's turn it into a program. a00x plus a01 y equals b1. a10x plus a11 y equals b2. We select this element as pivot. Applying Gauss Elimination Algorithm, minus a10 over a00 parenthesis a00x plus a01 y equals b1. a10x plus a11 y equals b2. We add up together. This term cancels out, minus 10x cancels out 0, plus a11 minus, we distribute a10 over a00 a01 y equals b2 minus a10 over a00 times b1. So y equals b2 minus a10 over a00 times b1 over a11 minus a10 over a00 a01. If we substitute this result for y here, a00x plus a01 y equals b1, x equals b1 minus a01 over a00. I missed y here. So this is the result. Now we test Gaussian Elimination Algorithm. Void test Gaussian Elimination Algorithm. I copy this function, paste it here. I will disable it. Double epsilon 1 10 e minus 5. Epsilon 2 10 e minus 10. Double a00, a01, a10, a11, b1, b2. We scroll up here, a00, e1, a01, 1, b1, 1. I set elements a00, a01, b1. a10 1 a11 1 b2 2 1 1 2. I applied this line here. Void Gaussian without pivoting double A00 double A01 double B1 double A10 double A11 double B2. Now scroll down, double y equal B2 minus A10 over A00 times B1 over A11 minus A10 over A00 times A01 double x equals B1 minus A01 times y over A00. This is why I applied this equation B2 minus A10 A00 times B1 over A11 A110 A10 A0 A01. This line, I applied this equation B1 minus A0 times y over A00. STD, Cout, Gaussian, without pivoting. And there, STD, Cout, x equals x, y equals y. And there, STD, and there, and there, STD. Now I copy the same function, copy, paste, Gaussian with pivoting, Gaussian with pivoting. If FABS control home include CMAS, scroll down, A00 is less than FABS A10, then we swap STD, swap A00, A10, copy once again A01, A11, copy once again B1, B2. This is pivoting. Now here, Gaussian without pivoting, A00, A01, B1, A10, A11, B2. Now we set A00 epsilon 2. I copy this function once again. Now I copy all, paste A00, E1. I will copy this one here. This is with the pivot. With the pivot. I will add one more here. I will modify it 17, 20. And it should be E3. I will copy once again E3. I will copy once again E3 or epsilon 3. Now in the command prompt, clang ++ pivot.cpp, hit enter. CLS. Now let's compare. I will close it. I will maximize it. Gauss without pivoting. When E1 is 10e minus 5, the result is x equals 1. It's almost 1. Y is almost 1. So this is correct. When A00 is 10e minus 5. When E2 or A00 is E2 is 10 minus 17. This is totally wrong result. This is incorrect. When A00 is E3 10e minus 20, this result is totally wrong. without pivoting. Gaussian with pivoting, when A0 is E1, E1 is 10, E minus 5. This is correct result. Gaussian with pivoting, x1 is 1, y1 is 1. When A0 is E2, this value. This is correct. Gaussian with pivoting, when A00 is E3, E3 is 10, E minus 20, this value is correct. So Gaussian with pivoting is always correct. Gaussian without pivoting is correct when E1 or A00 is not very small, but A00 becomes very small number. Gaussian without pivoting, this is wrong, this is wrong. I hope you understand the importance of pivoting. If we don't use pivoting, Gaussian elimination algorithm does not work. In my next episode, I will explain what is simple pivoting, what is partial pivoting, what is scaled partial pivoting, and what is complete pivoting. Pivoting is really important. Please subscribe to my YouTube channel. Thank you for watching.